Hi there, my name is Michael, and today I just want to quickly talk about a topic that many people find to be quite difficult, and that's probability. So, what I'm going to do is I'm going to start by just explaining the rules of probability, and then after that, I will then do a question with you. Right, so let's start. So, what we have is solving probability questions. Right, so what is probability? When we think of probability, what do we mean when we say probability? Now, according to the definition I have here, probability is the likelihood of something happening. So we're looking at the chance of something occurring, but we're not looking at that chance on its own. We're looking at the total of chances. So we're looking at the total number of chances that we have of something happening, and then we're looking at what chance we have. So we want to look at two things, two extremes here. If it's impossible for something to happen, then the probability of that would be zero, as we can see on here. If we just highlight that, impossible would be zero. Now, the probability of something definitely happen, no other chance, but you know that is definitely going to happen, then it would be 1. So say, for example, the probability of the sun rising in the morning is 1 because it's definitely going to happen. And then if we add all the probabilities, so the summation of probabilities should be equal to 1. So we have an equation here, or sigma, saying summation of probability should be equal to 1. So sum of all probabilities should give us 1. Now, how do we calculate probability? We calculate probability by looking at the total chances that we have for something happening, and then we look at the chance of what we are looking at. Now, say, for example, if we're looking at when you're playing a football game. So if you're playing a football game and you're looking at the probability of either winning, losing, or you're looking at a draw. So let's say we're taking the probability of a win. That would be, there's one chance here. You have one chance of winning out of 3, and you have one chance out of winning out of 3, 1 out of 3. So you are looking at then the probability of getting a win would be a third. So if we're going to write it down, we'll then write it down as the probability of having a win is equals to number of chances divided by total number of chances. So that would be a third. Now we want to look at more examples here, so that we get used to the idea of probability. So another example we could take here could be the example of a coin. So let's say we have a coin here. A coin, we can still connect it to the football, where when they start the game, they toss a coin to see who gets to kick the ball first. Now, when they toss the coin, they can either get heads or tails. So now the chances of getting a head if you toss the coin is 1, and the total chances would be 2. So what we'd have is we'd then have the chance of that happening would be 1 over 2. Now, for both of them, either tails or head would be the same. It would be 1 over 2. Another example we can look at would be an example of a dice. Some people like to call it die, but that's besides the point. We're looking at the total chances. Now, if you throw a dice, I've got 2 there, but let's just look at 1 for now. And then we can always look at the chances for 2 dice when we start looking at the rules of probability. But here we're looking at, if you throw 1 dice, the total chances is 6, and let's say the probability of getting a 6 is 1. So what you then have is you will have 1 in 6 chances of getting a 6. So that will be a 6th. Then if we're looking at the probability of getting odd numbers and even numbers, we're looking at the number of chances we have. So here we've got the odd even numbers that we have is 2, 4, and 6. So that should give us 3 chances. So we're saying there's 3 out of 6 chances of getting even numbers. So it'll be 3 divided by 6, and that should be 1 over 2. So there's half a chance of getting even numbers. The same for odd numbers. The odd numbers we're talking about 1, 3, and 5. What is the chance of getting a 1, 3, and a 5? And we're looking at them together here. So again, like the even numbers, number of chances. So number of chances will be equal to 3, and total chances, which I'll write as TC, is equals to 6. So we then have 3 over 6. Again, that's half a chance of that happening. Now we could look at also the probability of opposites. Now remember we said the summation of probabilities was equals to 1. So we can do it the long way or the quick way. So let's start with the long way, and then we'll look at the quick way, which is the formula there, where we're looking at the probability of something not happening, and then we just subtract it from 1 because we know that the total is 1. So let's say here we wanted the probability of not getting a 6. Probability of not getting a 6 would be 1 over 5 plus, that's 1 over 6 for 6 chances, plus 1 over 6 plus 1 over 6 plus 1 over 6, 1, 2, 3, 4, plus another 1 over 6. That's a total of 5 out of 6 chances. So the probability of not getting a 6 would be 5 over 6. Or we could simply say the probability, total probabilities, which is 1, probability of not 6 would be 1, which is the total number of chances, minus the probability of getting a 6, which is 1 over 6. Which should give us 5 over 6. So that's how we could do it. And that's how we do the probability of opposites. Now let's look at the rules of probabilities. Now you could be given a question where you have to consider more than one probabilities. Like for example, the 2 dice, you could be looking at the probability of getting 2 for both of them. So that would be, you'll be getting the probability of 2 and 2. So you need to multiply. So what we have here is we have the probability of something happening and something happening. So we need to consider 2 things here. We need to consider whether these 2 are independent. So let's say, if we take an example, let's say you want to go into town. And you want to go into town and you're looking at the probability of either going to the movies or going shopping. Now, you want to consider whether these 2 depend on each other. Now, if you do get to town, going to the cinema doesn't depend on you going to the shops. Because you could go to the shops, then straight after you could go to the cinema. Or you could go to the cinema, then straight go home. So what we want to look at, if you have 2 independent chances. So let's say, for example, the probability of you getting into town would be you could go to the cinema, to shopping, and you could do something else. That would be, total would be 3 chances. Then the probability of going to the cinema is 1 out of 3. And the probability of going to the shops is 1 over 3. So if you ask the question, what's the probability of going to the cinema and shopping? That would be 1 over 9. Another thing that you would need to consider is when they're dependent. So we could take the same example. So let's say we take that same example of going to town, and this would depend, right? It says it would depend on you going to town if you need to go to the cinema or to the shops. That depends. So now this is a dependent event. So now we're looking at the probability. So we could be looking at the probability of going to town. Let's keep it simple there. And we just say the probability of going to town would be 1 over 3. Then we would multiply it with the probability of going to the cinema if you go to town. That would be 1/3. Now, with other questions, obviously you would get a different answer, but this one we just get the same answer because I've simplified it in a way. Now, those are the rules of probabilities. We're going to be applying them in a question that we're going to be doing in a minute. Now, let's look at the other rule, the OR rule. The OR rule says you need to add, but again, it depends on two conditions. This depends on the probability or the condition of whether it's mutually exclusive or not mutually exclusive. What do we mean by mutually exclusive? Mutually exclusive events are events which prevent each other from occurring. So it says here, this is when the occurrence of one event prevents another event from happening. So for example, here I've put an example of bus and the train. So let's say we're keeping that example of going to the cinema and going to town. For you to get to town, maybe you need to get the train or you need to get the bus, but you cannot be on both of them. So those are mutually exclusive. The moment you get on the train, you stop yourself from going on the bus. And if you're looking at that now, you'd be looking at the probability of A plus B. The question could ask you, what is the probability that you get the bus or the train to town? So you're looking at those two and you're adding them together. Another one you could have is where they're not mutually exclusive. Now, when they're not mutually exclusive, you need to consider two things here. You need to consider the probability of A happening, the probability of B happening, and the probability of A and B happening at the same time, and you subtract them. Now we're going to look at an example that I have here, and this example would consider this fact where we're looking at the probability of A and the probability of B, and then we subtract the probability of A and B happening at the same time. So we've got an example here where we have mail orders, buyers of brand X, classified by area and age. So we've got the area north, west, east, and south, and we've got under 25s, 25 to 44, 45 to 64, and 65 plus. Now we're going to first of all look at the rules that we need to use.